Hi and welcome back. This week in maths we've been looking at area, and yesterday we started looking at the formula for how to find the area of a shape using the height times the width to find you the area in centimeters, meters or kilometers squared. And today we're going to look at how you would find the area of composite shapes. Now composite shapes are shapes that aren't one shape. They're usually two shapes put together, or they're just not necessarily a perfect shape. So they might have, because when you're finding the area of like a floor plan of a building, they're not always going to be a perfect rectangle. They're going to be like this, where they're going to have different corridors or different parts of a room. And it's not always as easy as just doing what's the length, what's the width, and just tying those together and then coming up with your answer. So what I want to do today is look at how do we break up shapes to find the area of different parts of the shapes and then add them together. So what I mean by that is if you have a shape like this, which is drawn pretty badly, let's just stay with me for a second. What I mean by this is if this was 4 centimeters, right? And this was 3 centimeters, this was 1 centimeter. No, it's not to scale. Don't come up in the comments and say how much my drawings aren't to scale. I know, I get it. This will give you everything that you need to know to find out the area of this shape. But just timesing this 4 by 4 is not going to get you the answer because there's a huge gap missing here. There are 2 different ways to do it, but let's look at the easiest way to do it. The easiest way to do it is to cut the shape across. Now you could easily cut the shape across that way, or you can cut the shape across like that. Either one is fine as long as you've got all the dimensions to solve each of those ones individually. In this shape, we know all of the sides, so either way we cut it is going to be fine. Let's try and cut it across like this. Now we have 2 shapes. We can solve this shape here and have the area up here, and then do a plus sign, then find the area of this shape up here and plus them both together. Just so you don't get confused, because quite often people get confused here. For this activity, we're going to color them in different colors. So we know exactly what the area, because quite often people will then go and they'll go, oh, 4 times 4, and they'll just get confused. Okay, so let's look at what the actual width of my shape is down the bottom. The actual width is 4. And the height of this part is 1. So that part is 4 centimeters squared. And then I'm going to plus that with the top shape. Now this is where people get confused. They go 4 by 1. But this shape is not 4 anymore. We are not looking at this side. That would take into consideration that. We are only looking at the purple side. And the purple side starts from here, which means the actual height of this shape here is actually 3. People using 4 times 1 is the biggest mistake that I find. So the actual height of this second shape is 3 by 1, and 3 times 1 is 3. Plus those 2 together is 7 centimeters squared. So by cutting the shape into 2 parts, you can clearly see how easy it is to just solve them. That shape by itself, 4 by 1, is so easy. You just have to cut them up properly and then choose the right sides. Okay, because I'll show you with the next one. Okay, so let's get over here and then look at this shape here. Once again, I could cut it down there. Because I cut that one across, let's cut this one down just to see something different. Like that. Now we have one shape here and 2 shapes here. So, the first shape. What is the full height of this red shape? If we look over here, the actual height is 6 centimeters. So it's 6 times, and acrossways, we don't count the 5 because this is only this part. This part is actually 2. That's the first shape here. The next one, people then sometimes count this, right? But it's only this shape now, so it's 3. So it's 3 times by 2 equals 6, plus those 2 together is 18 centimeters squared. Okay. This shape here, you can clearly see it looks easier just to cut that bit off the edge, which I understand. But if we cut that off, we don't have an area and length there. So if we cut this shape here, it's 1 by, there's no length here. But by process of elimination, we can actually find that out. So let's color that in there. Like I said, you don't have to color it in. I'm just showing you so you guys know not to get confused with the two shapes. Let's solve the easy part first. The width of this shape is 5 centimeters. And the height of this shape here is 4. Coming up with 20 centimeters squared is not the hard part. The hard part is now, what does this equal? Now, if we know if from here to here is 7, and here to here is 4, okay, let's draw it here actually. If this to here is 4 centimeters, but the whole one is 7, then this part here has to be 3, because 4 plus 3 equals 7. So the 3 actually goes here. Now we know the height of this shape is 3, and the width of this shape is 1, so you can do 3 times 1 equals 3, plus those two together is 23 centimeters squared. So composite shapes, it's really important that when you cut them across, you're looking at the right area. You don't go 1 by 7. You've only got to look at the shape you cut it. That's why me drawing in the colors for each of those two shapes just reminds me about how big my actual shape is. Okay? It might be something you want to try if you're constantly getting confused with this. Now I've done a different shape over here, and this shape here is like a square, but it's got a hole in the middle. So let's see if we can figure this out. Now I know it's a square because it has these lines here, which means that all the sides are equal. And if I know that all the sides are equal, then I know that that's a 6, and that's 6, and that's 6 centimeters, right? So let's find out the whole square area for itself. So 6 times 6. 6 times 6 is 36. So if there was no hole in the middle, we know that would be 36. Now what we're going to do is we're going to find the hole in the middle, and then we're going to take it away, because we're basically taking a chunk in the middle. Now I know this is also a square because it's got these lines here, which means all the sides are equal. Okay, so that's 2 and that's 2. So if I do 2 times 2 here, we can see that's 4 centimeters squared. Okay, so if I know the whole shape's 36 and the whole is 4, if I did 36, take away the whole, which is 4, I end up with 32 centimeters squared. So you can find shapes like this sometimes by finding the whole area and then just cutting out the hole, rather than some other way like cutting this shape up like this. You don't need to do that. You could just find the whole shape and then just take away the hole in the middle. I hope that's helped. What I'm going to do is I'm going to rub this off and write one more extension question just to sort of test some people and see if we can sort of pushing them a bit further. But if you feel like this is as far as you can go, just watch the next one. And if you don't understand, that's fine. But if you really feel like you want to push yourself a bit further, stay tuned, because I'm going to put one more question up at the end. All right, let's see if we can do that one. Okay, so here's the question. It is a little bit tricky, but let's look at some of the ways that we can try to solve it. Let me just grab my ruler. Okay, so we can see here that not only is this composite shape in quite a few different sections, so you'd have to cut it probably once, twice, or once, twice. So you cut one here, have this big shape here, and then these two shapes here. That's also possible. What is also possible in a shape like this is to do what we said with the hole, is to pretend like that goes all the way across, right? Solve the whole rectangle and then just take away that part there. That's how I would do it, but either way is fine. The main thing is that you get all of your dimensions right. That's why I'm going to do it my way, which is basically pretend like there was a hole in my rectangle, solve the whole rectangle as one algorithm, and then just take away the hole. So let's do it like that. So I'm going to look at the whole rectangle first. So it's 9.5 times 6.8 for the whole thing. So 5 8s are 40. 8 times 9 is 72. 72 plus that is 76. Next row down here, 6 5s are 30. 6 9s are 54. 54 plus 3 is 57. Go down here and go 0, 6, 14, 6. Now remember to go back once, twice, once, twice. So the whole rectangle itself is 64.60. All right, let me rub this out. Now that I know the whole shape, I'm just going to try to solve this part here and then just take it away at the end. So the length of my shape here, the width of my shape is 3.9, and the height of my shape is 3.4. So I'm going to do 9 fours are, my brain's gone, 36. 4 times 3 is 12, 12, 15, second row, 27, 11. Okay, now plus down, 2, 3, 1, go back once, twice, it is 13.26. So then I just take away that. Let's see if I can do this quickly. 51.34 centimeters squared. Now I'm going to quickly check to make sure that's correct, because I'm pretty sure it's correct, but under pressure sometimes I make little mistakes. But effectively that's how the strategy you would use. You would use, if it's easier with like lots of different parts, that might be easier just to solve the whole rectangle and then do that. Otherwise, like I did say, it is completely fine if you wanted to do 9.5, but then you'd have to find out if that's 3.4, then that's 3.4. It gets a little bit tricky. And then you end up solving 3 different algorithms just to solve it, where you could do it just in 2. I hope that's helped. If you're up to this part and you feel like this is okay, in the maths section in the activity for today, try to attempt the harder questions, because I think that will really push you, and hopefully you can give it a good go. And tomorrow we're going to look at finding the area of triangles. Okay? Thanks for watching.